Linear functions can be rearranged to look like they're in a different form than what we're used to, which is probably the one where y is isolated. That's called slope-intercept form. They can be rearranged, but they're still considered linear functions, and that leads us to other forms. One form is called point-slope form. I'm going to start off by showing you some examples of linear functions that are in point-slope form, and I'll also show you some non-examples to see if you can figure out what the pattern is, what makes something in point-slope form and something else not. I'll leave that up there. If you want to pause your video for a second and try to figure out what the pattern is, that would be a good challenge, but I'll take you through what the criteria are now. So to be in point-slope form, you have to have y minus the y value of a single point on the line on one side of the equation, and it doesn't matter which one. These two have it on the left, this one has it on the right, that's fine. And on the other side, you would have the slope times, so in brackets, x minus the x value of a point on the line. This is a way to write this, generally speaking. So m is the slope. It's the same m as y equals mx plus b. You have y, like the actual variable y, minus y1, where y1 is the y value of a point, and x minus x1. A couple of things to note here. So first of all is that it doesn't matter which side of the equation the y minus y1 is on. The second thing is that the slope can be a whole number, it can be a fraction, it can be a negative number, it doesn't matter. The slope is what the slope is. And the other thing is, you might say, or you might be wondering, if it's x minus x1, does it always have to be a minus sign? Can it be a plus? And the answer is that it can be a plus, because the x1 value itself could be negative. So what this means is, in this form here, in this example, the point 2 and 4, x is 2, y is 4, 2 comma 4, that's a point on this line. And here, the point on this line would be 1 and negative 5. The y value would be negative 5, because the y value in question always comes after the negative sign. So this really would be like it's y minus bracket negative 5. That's the y value there. And this point here would be the point negative 3 comma positive 9. It's always the value after the minus sign that you're reading. That's called a fixed negative in math. And how could you convert? If you were given an example in another form, how would you convert to point-slope form? Well, first of all, you'll need to find the slope. Depending on the form, you might already have it. And you'll also need a point, any point, x1, y1, on the line. Then you can plug in. So I'll show you how to do that. Supposing you had this example is in slope-intercept form. So I already know the slope here. I know the intercept. So I've got my slope that's negative 3. Now when you plug in a point, you shouldn't use one of the intercepts. That's something that I didn't mention. Your x1, y1 should be a non-intercept point. You can pick any point you like, and what's cool about a linear function is that it allows you to generate infinitely many points. You just pick an x value, any x value you like. Let's say I picked x as 1. I would plug that in as the x value. So I'll plug it in as my x, and I'll solve for the y that corresponds to that 1. So I would do negative 3 times 1 plus 8, that works out to be 5. My y1 is 5. So when I plug that in to this format, I would get y minus the y value that I just found. That'd be y minus the 5. My slope I know is negative 3. And when I plug in my x1, it's going to be x minus the x value that I picked. That's it. That is the answer in point-slope form. Because you can choose your x and find the y that goes with it, there are infinitely many answers. I could have picked x as 2. And if I picked 2 as my x, I would have had negative 6 plus 8, which is 2. If I had a 2 here, I would have had a 2 here. If I picked x was 3, let's say, it would be negative 3 times 3, which is negative 9, plus 8 is negative 1. I would have had a 3 here, and I would have had y minus negative 1, which would have been written as y plus 1. So you can have a plus there if your actual coordinate, your x coordinate or your y coordinate, is a negative number. And suppose I had this example, example 2, and I asked you to convert this to symmetric form. Well, here I don't have that shortcut of already knowing the slope, so I've got to find the slope first. How can I do that? I can find 2 points on the line, and I can calculate slope, or I can isolate y. And if I do that, then I know that once y is isolated, this is slope-intercept form, this coefficient of x is my slope. I know that the slope of this line is negative 7 over 5. Now I need a point on the line. How do I find a point on the line? Well, like I did before, I can pick any x and solve for any y. Supposing I chose x as 2, and I plugged in 2 as my x value, and I could have plugged it into the isolated version, it doesn't matter. Then I would get, when I isolate my y, I would get negative 14 plus 1 equals 5y. That works out to be negative 13 over 5 as the y value that corresponds to 2. It doesn't matter that it's a fraction. When I plug that in, I would get this. I'd get my slope, which is negative 7 over 5, times x minus the x1 that I picked, equals y minus the y that I found that matches, that corresponds with that x value that I picked. And because I have this minus minus, I would rewrite that as a plus, more likely. Now this is fine to write it this way, but more likely I'd write that as negative 7 over 5 bracket x minus 2. And on this side I'd have y plus 13 over 5. And that's it.